cylindrical coordinates, you don't have to worry about z because cylindrical is z, but x and y are polar coordinates, right? So we just have to figure this out. We have to change that to r dr d theta. And this part needs to be changed into r and theta. So what is this? Well, since that has dy and dx, think of this as y equal to 0 and y equals to square root of 1/4 minus x squared. And then x goes from negative 1/2 to 0, right? Now, y equals to 0. Remember, this is surface to surface, curve to curve, point to point, right? So right now we're talking about curve to curve. In other words, you have to think about y equal to 0 as an equation of something in the xy plane. Okay. What does y equal to 0 give you in the xy plane? If you have y equals a number, it's always a horizontal line, right? So y equal to 0 gives you the x-axis. Okay. All right. What about this one? What does that give you? Well, in general, if you have a squared minus x squared, that's a circle that's radius a, and it's just the top half part, right? So this is a half circle of radius a. And you can quickly figure this out by just squaring both sides and moving the x squared over this way. You get x squared plus y squared equal to 1/4. So the radius is square root of 1/4, which is 1/2. So this is a radius 1/2 circle. So it seems like because dy is inside, you're increasing in the y direction. So you start from 0 and you end at the top half circle. So this seems to be what you get. But look, however, the x only goes from negative 1/2 to 0. So it's not the full circle because you start from negative 1/2 to 0. It doesn't give you this much. Okay? So x goes from negative 1/2 to 0 means you're only looking at this part of this region. So what you're getting is this quarter of the circle. Okay? All right, so now let's think about how to paint that region. It's 1/2. How do you paint this region in terms of dr d theta? Well, first, dr means you're painting this region radially, right? You start from here, you end there. Okay? So when you're here, what's the value of r? 0. R equal to 0 is the origin because r is the distance from the center. Right? It's this distance from the origin. Okay. So here, r goes from 0, and where does it end? 1/2. Not negative 1/2. This point is still in polar coordinates is 1/2 comma pi. You're only in the pi direction and you're going 1/2 steps. So r is not negative 1/2 there. This is r equals to positive 1/2, right? So r goes from 0 to 1/2. What about theta? The angle is from
90 to 180.
Yeah, and you have to change that to radians, right? So pi over 2 to pi. Okay, great. So that means this integral can now be written as integral from pi over 2 to pi. R goes from 0 to 1/2. And then integral 3x squared plus y squared. And then square root 1 minus x squared minus y squared, x squared plus y squared plus z squared. These I didn't change yet, but now we have r dz dr d theta. Okay, so we've made a great progress. However, I still see x and y. These need to change. Okay. Now, in many cases, you're going to see x squared plus y squared appearing several times when you go from Cartesian to cylindrical because, see, r is equal to square root of x squared plus y squared. So that gives you a quick and easy way to convert x squared plus y squared. What's that equal to? r squared, right? So you can rewrite these as r squared, and therefore in cylindrical coordinates you have pi over 2 to pi, 0 to 1 half, and then square root of 3r squared, and square root of 1 minus r squared plus z squared, r dz, dr d theta. We still have a z, but that's okay because cylindrical coordinate system is r theta and then z is same as the Cartesian. You could cancel this 2 with the square root and rewrite it like this. Square root of 3 times r. That makes it slightly better. Don't try to cancel these two though because of 1, it can't cancel. This squared and that square root cannot cancel because of this one. Okay, so that's your cylindrical coordinate system. Now let's work on the spherical coordinate system. If sometimes the question would just ask you to go from Cartesian to straight to spherical, but in such a case, it's still a good idea to go through the cylindrical first because it gives you a lot of hints, especially because theta in the cylindrical system is same as the theta in the spherical system. Okay, and whenever you go from the cylindrical to the spherical, you have to keep in mind of this picture. Okay, so you know how I explained that spherical coordinate system is x, y, and z, and then you first, if you have a point in space, you first open a book. So when the book cover hits that point, when that this plane hits that point, the amount of angle that you open the book is called theta. Okay, but then once you have that point in this page, in that plane, then you can draw a right triangle. That's this picture right here, okay? And the length from the origin to that point is called rho. This length is the cylindrical coordinates r from the cylindrical coordinate. And of course this length is z because that's the z coordinate. And the angle from the North Pole to that point is what we call phi. And from there, we have several nice equations we can use. One of which is like rho equals to z times what? Z times z. Oh, sorry, I got it backwards. Z equals to rho times cos phi. And then r is equal to rho times sine phi. You can also use the Pythagorean theorem to get what? Rho squared is z squared plus r squared. So these are some equations that come in handy. All right. Now in the cylindrical, it was relatively easy because we just had to go from xy plane to the polar. So it's just by nature just a two-dimensional question. But spherical coordinate system only works in 3D, so you really need to have a three-dimensional integral involved. So you need to know what this means in order to write in spherical. About a month ago, sorry for going back so much, but if we recall that z squared is equal to x squared plus y squared, that was a double cone. We learned that at some point, right? Okay. And if you solve this and write this, you just get top half, because z is positive, you just get the top half of this. And this is like multiplying by square root of 3, so it's just, you take this and you lengthen it a little bit, so that's going to be a sharper looking cone. Okay, so that's what this bottom one is. Oh, again, remember it's surface to surface, curve to curve, point to point. So we're really looking at z equal to 3 times x squared plus y squared, as if this is an equation of a surface. So the surface that we're talking about is this cone that's kind of sharp. Okay? So that's what you have. And then what about z equals to square root of 1 minus x squared minus y squared. Well, for this one, you can square both sides and then move x squared y squared to the left, so you get x squared plus y squared plus z squared equals to 1. What's that? Sphere. And because z is square root, it only gives you the top half of the sphere. So you have the top half sphere. So what's happening is that you start from this cone, some point on this cone, you go up because you have dz covering here. So you get some kind of like ice cream cone type thing where the top is a bit round. That's the region that we're in. Oh, okay. All right. So once you get that picture, now let's see what's happening afterwards. So you start from here and you go up there, and you flatten this like a pancake. Once this integral is done, it flattens like a pancake. So now it becomes an integral over here, downstairs here, right? But remember, we weren't getting the full circle here, right? Well, we only had the quarter circle. It was this one, right? So I said it's like a ice cream cone, but it's not the full ice cream cone. It's really just the portion of the ice cream cone over this picture, like that. You get that? So over this picture, you start from the portion of the cone until you hit the sphere. That's what's happening. So it's as if you bought an ice cream cone like this one, and 4 kids wanted to share it, so you cut it like that, okay? And then you have a 1/4 at your hand. That's what you're doing. Okay. So given that, how are we going to integrate this? Well, so in any of these integration questions, once you get to 2D or 3D, it's very important that you first have the picture. Do not try to solve any of these questions without having the picture. You need to have the picture first, okay? And that's what we did. We have a good idea of what that is. But then we need to cover that. I don't know if I can do a good job there, but here's like so it's like you slice the ice cream cone in 4 equal parts, and this is 1/4 of a cone, okay? All right, so we're trying to paint this region by d rho first. Remember, dz, dy, dx, we learned that this is rho squared sine phi, d rho, d theta, d phi, okay? So we need to now talk about this region, trying to fill that region with respect to d rho. But what's d rho? D rho is the distance from the center, so you're trying to fill up this space from the center radially, okay? So this would mean rho goes from where to where? Rho goes from, what is this point? 0. And when it hits this, notice that it never hits the cone. It's like along the cone, but it hits the sphere, right? So when it hits the sphere, it'll be 1 because the sphere is radius 1. I erased the equation for the sphere, but this one you can see that it's a sphere of radius 1. So rho will be between 0 and 1. Okay. So that part is okay. However, now the question is, when you go think about, okay, theta is same as before. Theta is pi over 2 to pi. That doesn't change. However, when you talk about phi, you now have to think about how far does it come down from the North Pole, okay? It definitely is, phi starts from 0 because it does contain, there are points in the North Pole, right? All of these points are in the North Pole. So phi should always start from the North Pole. But then how far does it come down? Well, for that, it's instructive to think about the xy trace of that. So let's work on that a little bit, okay? So first, you take this equation, square both sides. You have z squared equals to 3x squared plus 3y squared. And we're going to take the xy trace. No, not xy trace, xz trace, which means you set y as 0. If you set y as 0, this just becomes z squared equals to 3x squared. And if you solve this, you get z equals to plus minus 3x, square root of 3x. Okay, so what is this? Z equals, these are two lines, right? There's one line that has a positive slope, right? There's another, this is square root of 3 times x, right? There's another line that is negative slope, negative square root of 3 times x. And then phi here will come down as far as this line, and that it stops. Does that make sense? Okay, it's gonna go from the top and go down as far as this point. And therefore, the goal is to figure out what this angle phi is. Okay, how do you do that? Well, here, unfortunately, we'll have to use some trigonometry, okay? So let's say we plug in 1 here. Then what is the y coordinate if we plug in 1? Square root of 3, okay? So that means we have this triangle where this is phi, this length is square root of 3, and this is 1. Tell me what this length is. Oh, well, you could... Yeah, well, let's try that. Okay, what is this length?
Red 10.
No. Red 4. Red 4, which is 2. Okay. Okay. Do you recognize this triangle? 2 square root of 3, 1 triangle.
Yeah.
It's one of the special triangles, right? What is this angle? You can guess, right? 30. This is 60, this is 30, right? Okay, because this is longer. This is the smaller angle than this one. Since the longer side is the opposite of this angle, the opposite of this angle is smaller than this one. This is a bigger angle, okay? So it's a 61. So if you knew the 60-30 triangle, that's wonderful, then you would know that this is 30 degrees, which is pi over 6. That's how far the roll would come down. Now, if you didn't, then still another way to figure this out is to just say tangent of phi is what? Tangent of phi in this picture is opposite of adjacent, right? Tangent is opposite of adjacent, so what is it? Opposite is 1, adjacent is square root of 3, right? And you punch this into a calculator, get the phi by taking the tangent inverse of this. Okay. And it's good. It's when you do this, it's a good idea to do it in degree mode rather than radian mode, because radian mode you wouldn't be able to see what's going on. But if you do the degree mode, you'll see that doing this calculation, you get exactly 30 degrees. Okay. So by doing that, you get 30 degrees either way, which means this is pi over 6. So that means phi goes from 0 to pi over 6. That's how far it comes down. Okay? And that actually explains why the circle down here is exactly 1/2 radius, because if this is 30 degrees, this angle is 60 degrees. So here's what you have. You have a 60-degree triangle with this length. This from the sphere was 1, right? So in that case, what's this length? This length will be cosine of 60 degrees, right? Which is 1/2. That's why this circle down here is 1/2. Okay. So that's why we're sure that this is the picture that you get. Okay? In fact, if this number wasn't 1/2 and something else, for example, it was like 1/4 or something, it'll be a lot more complicated. It'll be very hard to do. Okay. All right. So with all this, here's what we figured out. We see that r squared plus z squared. Let's leave it as this for now. Oh, not this one. This for now. But r dz dr d theta will now be changed to rho squared sine phi. So this much is dv, right? Which is same as dz dx dy dx. And it's also same as rho squared sine phi d rho d theta d phi. And again, there's no universal agreement on the order. This is the one that I like to do. Some textbooks might have the order slightly different, but it's customary to always put the rho inside. Okay? These two might be different depending on your textbook. Okay, so let's continue on. For d rho, we decided it should be between 0 to 1. For d theta, we decided it should be between pi over 2 to pi. And for d phi, we just figured out it's between 0 to pi over 6. Okay, so we are almost there. The only difference now is that this r squared plus z squared should be now changed to rho, but we just did that. This is rho squared, right? In that picture that I just erased it, but this is equal to rho squared from the picture that, this was the picture. Z, r, rho, phi. So z squared plus r squared is phi rho squared. And therefore you get 0 to pi over 6, 0 pi over 2 to pi, 0 to 1, rho squared times rho squared is rho to the 4th, sine phi, d rho, d theta, d phi. Okay? That's the answer. Now, if you try to do this integral, you'll have nightmares. I actually wouldn't want to do it yet. So this is too much. Right? But look, these are just numbers, right? This is a lot easier. I think we can actually do the calculation. Let's see. What is this? This is a 1/5 rho to the 5th power. Yes.
Oh, I was gonna say, do we have to evaluate it or
no? It's just as conversion, and you don't have to evaluate it. But sometimes I say convert and evaluate. So in that case, this one, if you integrate, it'll be 1/5 rho to the 5th power, and you plug in 1 and 0, so you get 1/5. And then you have to integrate theta 1 by theta, so you have to do this one, pi and pi over 2. You still have to integrate from 0 to pi over 6 for sine phi, d phi. So that's pi over 10. Integral of sine is negative cosine. Negative cosine pi over 6 is right equal to 3 over 2. Cosine 0 is 1. So it's 1 minus this. Okay, so the final answer is pi over 10 times 1 minus square root of 3 over 2. I think, yeah. That's the answer. But yeah, that's not the answer. This is like if the question is asking for you to integrate. This is the answer for spherical. This is, did I erase it? Oh, I guess I did. Oh no, this is the answer for cylindrical. These are the answers.